Hello everyone, welcome to the 8085 programming series. Today we're doing the program that's 10 bytes of data stored in memory location starting from 8040 and from 8050. So we need to write a program to interchange the data bytes. So whatever is in 8040 will come to 8050 and whatever is in 8050 will come to 8040. So it is an interchange. So we have 10 bytes starting from 8040 to 49 and 8050 to 59. Let us see the program. So this is the required program. So what we do is LXIH 8040, we initialize the memory pointer, and we also store the data. So in this you can see the data we have stored. This is the data at 8040 we stored 10, then 20, 30 in this continuous, and then in from 50 we are storing some different data, so that when we run the program we will see that the data actually gets interchanged. So before running the program, what we have at 8040 is 10 and at 8050 we have 11. So when we run the program, this 10 will come here and this 1 will go up, and similarly for 8041 20 it is 20, 8051 is 22, so this will go here and this will go here. Okay, so this is the interchange of 10 bytes of data. Only few are mentioned, but when we do the program we'll store the data. So first of all we initialize the HL pointer. So this is where with LXIH 8040 80 gets stored in H and 40 in L, and this also becomes our memory pointer. Then with LXID 8050 we have, this is the DE where we get this DE, okay, 8050, our memory pointer. So with LXID 80 gets stored in D and 50 in E, and it also becomes a DE pointer. With MVIC 0A, because it is 10 byte of data, so this 0A means 10, because in here we have to store the data in hexadecimal notation. If we store 10, it becomes 16. So 0A means 10. Then the very first instruction is move B comma M. Okay. Now why we are storing the data in register B from the memory location M? Because this M can be accessed by any of the register apart from A, also A, not only apart from A, but any register can access this memory location, okay, M, A and all the other registers. Okay, so the very first thing we do is move B comma M. So the data which is in this memory location pointed by HL, it gets stored in register B. Okay. Now LDAXD, what happens with LDAXD? The data which is in DE pointer, which is pointed by DE, that is 11, it gets stored in register A. Now this pointer D, can only be accessed by A and not by any other register. Therefore we have done the first step. In the first step we have stored the data from memory pointer M, from memory M to B. Okay, and because only A can access the D pointer, therefore we store the data from D pointer to A. Now next step, what we do, move M comma A. So data which is in register A, it gets stored to memory location this one. Okay, so this will become 11. Okay, and then with the next instruction what we have to do is we have to store this 10 to memory location 8050, but register B, it cannot access the DE pointer. So what we do, we store this data 10, okay, to register A with this instruction. So move A comma B, it will store the data from B to A. Okay, and then STXD, the data which is in register A, it gets stored to this particular pointer, and this becomes 10. So this 11, the first interchange is complete. Then next instance INXH, with INXH this 8040 becomes 41, INXD 8050 becomes 8051. With DCRC the counter decrements, becomes 9, and because it is not 0, it gets ready for the next interchange, and this will continue until the counter becomes 0. Okay, so this is how the program runs. Let us run it on the simulator. So this is our simulator. I've just typed the code. Okay, so LXIH, LXID, MVIC, all the codes have been written. So I'll just assemble it. After assembling we get this. Okay, now before running the code we have to store some data into the memory location. Okay, so remember, first we have to assemble it and then store the memory data. Okay, so here what we do is okay, I'll just come here, store directly to the specified memory location. So I'll just come to this memory location, the top. Okay, then 8040. Okay, and then I'll store here 10. Okay, and then with 8041 I'll store 20. Okay, and this I will continue. I will also use so 8040 is 10, 20, 30. Okay, up to 8049 we will have A0, and from A050 we will store 1, 1, 2, 2, 3, 3, and so on. So I will store it quickly to save time. So I've just stored the data. As you can see, 8040 is 10, then 2030 up to 8049 we have A0, and from 8050 we have 1122 up to AA. Okay, so after executing the code, what we'll see, this 10 will come to the place where we have 50. So this 11 will come up, and then 10 will go down, and 20 will come in the place of 22, and 2 will come in the place of 20, and so on. Okay, so now let us switch to registers, and then I will just go by step. Okay, so we just, with the first instruction, as we know, 8040, so 8040 will stored in HL. With 8050 will stored in DE. With MVIC 0A 0A will stored in register C. Now with the first instruction, move B comma M. Okay, so whatever data is in register in the memory location pointed by HL, that is, it has 10. Okay, it gets stored in B. As we can see, it gets stored in B. With LDAXD, the data which is in D pointer, and we know that 11 is there, and 1 will get stored in register A. So this is what we get, 11. Okay, and with move M comma A, the data which is in A will get stored to memory location pointed by HL. As we can see here, this is as you can see here, this 40 it becomes 11. It was 10 previous, now it becomes 11. Okay, and with the next instruction, the data from B gets copied to A, and then with STAXD, the data which is in A, okay, which was transferred from B to A, that was 10 was transferred from B to A, and from A to memory location. So as you can see, this becomes 10. Okay, so this one has been interchanged. Now with INX H, this becomes, the pointer becomes 8041, and INX D, it becomes 8051. With DCRC, this C becomes 9, and because it is not 0, okay, as the 0 flag is not set, so it will go up. Okay, and this will continue until all the data bytes have been transferred. Okay, and when C becomes 0, we can see this 0 flags it sets, and it gets out of the loop. Okay, so this, so you can see now this has become 1, so it will do once more. Okay, when C becomes 0, okay, as you can see, C becomes 0. Okay, and C becomes 0, and 0 flag is set. Okay, so that this condition becomes false, G and Z becomes false, and hence it comes to the halt instruction. And when we check the memory content, okay, we'll see that all the data has been interchanged. As we can see, at 40 we have 11, 22, 33, 44, and from 50 we have 10, 20, 30, and so on. So that's all for this particular session. Thanks for watching.